Alright, so video 3, a big thing we do in calculus is practice getting to one variable. So here's a problem. Rectangle has an area of 25 centimeters squared. They want the perimeter of the rectangle expressed as a function of the length of a side for the first one. So if you think of what that's asking for, they want the perimeter as a length. They want this equation right here, where this is L. Now, first thing we better realize, if that's what we're looking for, is that they told us that area of a rectangle is length times width, and that the area is 25. So 25 would equal LW. And I also know that if I think about the perimeter of a rectangle, perimeter is equal to, in this case, 2L plus 2W. So right now, that function is two variables, L and W. I guess I gotta get rid of W. Well, think about it. This is an easy one to solve. W, right, is going to equal 25 divided by L. So if I take this equation, 25 divided by L, I can come down here and actually just plug in for W. So P would equal 2L plus 2 times 25 divided by L. And now we have a function that meets this requirement. And if I wanted to make it so it looked like a function, I could just put the L inside there. The second one I have today is express the surface area of a cube as a function of its volume. Now, if you're trying to think of a picture of a cube, if I jump here to the internet, here's a cube, right? And it's 6 surfaces that are squares, all right? And I'm going to call this the length, this the length, this the length. So right away, when I think about a cube, based on our knowledge, hopefully you guys are all thinking to yourself that the volume of a cube is equal to the length cubed. At the same time, the surface area of a cube has 6 sides. 6 times what? Well, 6 times. Each side has L times L, so how about L squared? So now they want us to express the area, the A, as a function of V. So I want to be clear about this at this point. We're trying to do A as a function of V. And right now A is 6L squared. If I was to type that, that's what's going on. But I don't want L here. I'm going to have to replace L with some V. So I come back up to this equation. V is equal to L cubed. Well, how do I get L by itself here? I take the cube root of both sides. So I could insert, at this point, I know it's a cube root of what function? V. And we have now just written the surface area of a cube as a function of its volume. Again, keep practicing. These problems take practice.